So in this problem you are given a system, right? The output of the system y of t is the input of the system x of t times the unit step function. So, and you are asked whether this system is time invariant or not. What I suggest you do is you first think about what the system is actually doing to your signals and get a feel for what's happening. So what is really happening is, if t is greater than 0, then the output is the same as the input, because this function is 1, right? U of t is a function that's 1 if t is greater than 0, and it's a function that's 0 if t is less than 0. And at 1/2 we at t equal to 0 we defined it as 1/2, but let's not worry about that for now. So if t is greater than 0, the output is the same as the input, but if t is less than 0, then the output is always 0 regardless of what the input is. So intuitively it seems to me that the response of the system, it's like the system has a gain of 1 or 0 depending on whether t is greater than 0 or t is less than 0. Would that be one way to characterize the system?
Yeah.
So clearly you can see that the gain is something that changes with time. It's a function of time, right? So it seems to me intuitively that the system is time variant, because there are aspects of the system which are changing with time. The gain of the system is changing with time. So this is a time variant system. But let's try to go through the math to see why that happens. In fact, before I go through the math, well, let's even pick an input and see whether we can shift that input by something and whether you would get a shifted version of the output, right? Just pick some input. Pick some simple input that you can play with.
Like numbers?
Your input has to be a signal, right?
Okay.
So how about some signal like this? So if this goes into my system, what will come out of the system?
Would be just 1.
So it's going to be exactly the same as the input, right?
Yeah.
Because the output of the system is going to be 0, and then for values of t greater than 0, the gain of the system is 1. So I'm going to get exactly the same as what goes into my system. Do you agree? If the system were time invariant, if I were to shift this signal by some amount, the output should also get shifted by the same amount. If that is true for all shifts, then we could say the system is time invariant. So if I were to shift the input by 1 to the right, what would happen to the output of the system?
Then the price 0. If you shift it to the right,
Yeah.
then it's the same.
It's the same, right? If I shifted the input by 1 to the right, then the output would also get shifted by 1 to the right. Do you agree? So in fact, for any positive value of shift, or even when the shift is -1/2, it looks like everything is going to be okay. But the real problem is this: what if my shift is -2? If I take this signal and I shift it to the left by 2, then what would happen to the output? Then my input would look like this, right?
Yeah.
And if this were to go into my system, what would come at the output?
It would be just 0.
It would be just 0 everywhere. Is that simply a shift of this by 2 to the left? No, right? So I shifted the input by 2 to the left, but the output is simply 0 in this case. It's not a shift of this output by 2 to the left. So clearly it's not time invariant. Right? Okay, so that's just playing with an example to see that it's not time invariant. If you want to really do the math, let's do the math and let's see where we get a difference. I will just scroll down. So we have this system x, y of t is x of t times u of t. So what is our test? Our test is to take some input. We call it x of t. We first pass it through the system, then we take the output of that system and we shift it by t naught to the right. We get some, so this is going to be y of t, and this is going to be y of t minus t naught, right? What's y of t? Y of t is x of t times u of t. What is y of t minus t naught? X of t minus t naught.
U of t minus t naught.
Very good. It's times u of t minus t naught. And then we take the same x of t, we first shift it by t naught. What are we going to get?
It's going to be x of t minus t naught.
Going to be x of t minus t naught. And now you pass it through the system. X of t minus t naught times what?
U of t.
There you go. It's u of t, not u of t minus t naught. So clearly these two are not the same.
But this problem had
So it is not time invariant, or equivalently it's time variant.